So for number 1 from the 2012 exam, it says a 1.22 gram sample of a pure monoprotic acid, HA, was dissolved in distilled water. The HA solution was then titrated with 0.250 molar NaOH. The pH was measured throughout the titration, and the equivalence point was reached when 40 mL of sodium hydroxide had been added. The data from the titration are recorded in the table below. So notice it tells you that you've reached your equivalence point at 40 mL, which tells you that the pH at that point is 8.62. Okay? So that's an important point just for you to imagine your titration curve. In A, it says, explain how the data in the table above provide evidence that HA is a weak acid rather than a strong acid. Okay? And so when you're at your equivalence point, since the pH at your equivalence point is basic, it's 8.62, that tells us that HA is going to be a weak acid. Okay? So you give yourself 1 point if you had the correct explanation. For B, it says, write the balanced net ionic equation for the reaction that occurs when the solution of sodium hydroxide is added to the solution of HA. Well, since HA is a weak acid, it's going to stay HA. Sodium hydroxide is a strong base, so it's just going to be OH minus. And then your products are going to be A minus plus H2O. Okay? And you don't have to put the states of matter. That's fine if you didn't. So you get 1 point for writing the net ionic equation with the correct charges. So notice they say balanced charges because OH has a minus charge and A has a minus charge. And then mass meaning the same number of atoms. So same number of hydrogen atoms, A atoms, and oxygen atoms. In C, it says calculate the number of moles of HA that were titrated. So we're going to use our equivalence point, which is at 40 mL. At your equivalence point, remember you have an equal number of moles of acid and base. So what I can do is I can multiply the volume of sodium hydroxide that was required to reach my equivalence point, 0.0400 liters, because I had to convert from milliliters to liters. Then I can multiply by the concentration of sodium hydroxide, which is 0.250. Now I'm in moles of sodium hydroxide. In order to get into moles of HA, I use the fact that it's a 1-to-1 mole-to-mole ratio, and I can get into moles of HA, which gives me 0.0100 moles of HA. So you get 1 point for the correct number of moles. In D, it says calculate the molar mass of HA. Well, it told me how much acid I used. I used 1.22 grams of my acid. In C, I had calculated the number of moles of HA, so by taking the mass and dividing by moles, I can figure out the molar mass of HA. And so you get 122 grams per mole. So you get 1 point for the correct molar mass. Next, for E, it says the equation for the dissociation reaction of HA in water is shown below. Okay, so that's showing HA dissociating into water to produce hydronium ions and A minus. It gives you your Ka. It says assume that the initial concentration of HA solution before any NaOH was added is 0.200 molar. Determine the pH of the initial HA solution. Okay, so if you look at what they did, they show their equilibrium expression. They show the concentration of H3O plus and A minus as X and X, and then the concentration of HA as 0.200 minus X. They didn't show an ice chart. You guys need to show an ice chart. Just don't skip that step. So they are missing their ice chart. The initial concentration of HA is 0.200. Initial of H3O plus and A minus are both 0. The change would be minus X and then plus X plus X. Remember, we're ignoring water. And then at equilibrium, your concentrations are what they showed there for their expression. Okay? Then make sure if you're going to eliminate X using your rule of 100, make sure to show your rule of 100. Notice they write it a little differently than we do, but that's fine. And so when you solve, you get an X value of 3.5 times 10 to the negative third molar. It's not asking for the concentration of H3O plus, it's asking for the pH, and so I'm going to take the negative log of 3.5 times 10 to the negative third, and I get 2.45 because I want 2 sig figs, so I have 2 decimal places. Okay. In F, it says calculate the value of H3O plus, the concentration of H3O plus in the solution after 30 mL of NaOH is added, and the total volume of the solution is 80 mL. Okay. So here, because you have HA reacting with OH minus, I've got to write out the reaction between the acid and the base. Okay, and you'd already written that before in B. Okay, so my initial concentration, just be careful. If you notice, their values are in moles. Okay, so you can write the concentration, that's totally fine. It's just going to be a tiny bit different at the beginning when you create your ice chart. But remember, because you're adding two different solutions together, your concentration of HA and OH minus are going to be different from what you initially had. So if you start off with 0.2 molar of the HA, to figure out the new concentration of HA, what you're going to do is take the concentration, 0.200 molar, multiply by the volume of it that you used, which is the 50 mils, and then you're going to divide by the total volume, which is 80. Okay? So you'll get a value that's different from their initial number of moles. That's totally fine. For the NaOH, you're going to take the 0.250 molar NaOH, multiply by its volume, which is 30, and then divide by 80. And so that'll give you the initial concentration of OH minus. Then remember, because it's a strong base reacting with an acid, one of them is going to react completely, and specifically, you're going to actually run out of OH minus. And so what you end up getting at the very end, your final concentrations, you have no OH minus. Your concentration of HA, once you do the math like they did using your ice chart, you should get 3.13 times 10 to the negative second molar of HA, and you should get 9.38 times 10 to the negative second molar of A minus. Okay? Now notice it's not asking about the final concentration of A minus or HA, it's asking about the concentration of H3O plus. And so what I would recommend doing, and they didn't actually do this, so basically what they did is they said, okay, I've got HA and A minus, I'm now going to have my acid dissociation reaction, so HA produces A minus and H plus, and then I'm going to redo this problem with the initial concentrations that are given, the 3.13 and the 9.38, and solve for my concentration of H plus now. Well, what I did was I said, okay, HA and A minus are your weak acid and your weak conjugate base. So I'm just going to use my Henderson-Hasselbalch equation. And so when you do the pH equals pKa plus the log of base over acid, the pH you end up getting is 4.68. Okay? And so when you get that, when you get the 4.68, then you can do 10 raised to the negative that in order to get your concentration of H3O plus, which I got to be 2.10 about times 10 to the negative fifth. So you can either use Henderson-Hasselbalch, or just like any problem that we've completed before, when you have weak acid and its weak conjugate base, you can write the acid dissociation reaction. HA produces A minus plus H plus. Start with the initial concentrations of 3.13 times 10 to the negative second, 9.38 times 10 to the negative second, and solve for your concentration of H plus at equilibrium. So you can do it either way. I think the Henderson-Hasselbalch way is easier. So really quickly going back to E and F, I forgot to go over the points for that. Okay, so for E you get 1 point for the correct substitution into your Ka expression, 1 point for getting the correct concentration of H3O plus, and 1 point for the correct pH. Notice, if you get the wrong, be careful, because if you get the wrong concentration of H3O plus, don't take off if you get the wrong pH. If your pH is correct based on your concentration of H3O plus, give yourself that point. Okay, and then for F, you get 1 point for the correct calculation of the moles of A minus and HA after the reaction. You would still get the same, you would still get a point if you, instead of finding moles, you found concentration. That's fine. You get 1 point for the correct substitution into the equilibrium expression, or if you want to use your Henderson-Hasselbalch, you would get a point for that as well. And then you get 1 point for the correct calculation of H3O plus.